In this section here, we're going to take a look at the rational exponents. So rational numbers, they're numbers that can be expressed as a fraction. Things like 0.5 can be expressed as a fraction. That would be 1/2. -7 could be expressed as a fraction. That's -7 over 1. 5/4 obviously is a fraction already. So anything that we can write as a fraction. It doesn't include things like pi, where the decimal repeats forever and we can't actually write pi as a fraction. So just anything we can write as a fraction. So we're going to be looking at fractions in our exponents. Now, a couple things to know is we've been working with exponents, and we know that 4 squared means 4 times 4, and that's 16. Should be familiar with the concept that the square root of 16 equals the square root of 4 times 4, and it's 4. So squares and square roots are opposites of each other. So if 4 squared is 4 times 4, 16 is the root of 4 times 4. What this asks is what is 4 multiplied by itself, and this asks what number multiplied by itself is 16. However, this is actually an abbreviation of the proper notation for it, which is the same sign, that same square root sign, but there should actually be a 2 in there. And that's because we don't just have square roots. Squares don't just have opposites, cubes have opposites. To the power of 4, to the power of 5, to the power of 6, to the power of 500. Those all have opposites, and they're all called roots. But instead of square roots, they're cubed roots, or third roots. They're fourth roots, or fifth roots, or 500th roots. And so if we take a look at the notation here, if we have 4 to the power of 3, well, that's 4 times 4 times 4, which is 64. Similar idea to our 4 squared. So our third root of 3, or cubed root of 3, the opposite is the cube root of 64, not 3, but 64. So the cube root of 64, what number times itself 3 times is 64? Well, 4 times 4 times 4 makes up 64, so the cubed root of 64 is 4. And we can calculate these various roots in a couple ways. Now, one of these that presents a problem sometimes is that your calculator might have a button for this, and you might have this. So if we try and do this one here, we're going to find the 6th root of 262,144. You might have this button on your calculator, but not all calculators do. I mean, I have this nice fancy-dancy graphing calculator. It doesn't have a button for doing anything but a square root. So there's got to be another way to do them, and there is. The other way to do them is to use fractions. So if I want the 6th root of 262,144, what I convert that to is 262,144 to the power of 1 over 6. If I type that in my calculator, 262,144 to the power of, and I'm going to put it in brackets because 1 over 6, if I don't, it's just going to do to the power of 1 divided by 6. So I got to put it in brackets so that it's to the power of 1 over 6. But if I hit enter, I get an answer of 8. So I got an answer here of 8. And I can check that because that means that 8 to the power of 6 should be 262,144, which it is. So whenever you have a root, that value there is the bottom of a fraction. So 1 over 6 in this case. And we can use that then to calculate some further questions. So we're just going to always put the xth root as 1 over x. So here we have the third root of 27. So that's 27 to the 1/3. And then when I typed it in my calculator, what number times itself 3 times is 27? Well, that works out to 3. And again, make sure that when you type this in your calculator, you put this in brackets. That needs to be in brackets. It doesn't have to be in brackets when you write it down, but your calculator, it does need to be in brackets because your calculator needs to follow the bedmass. Same idea on the next one. If I want the 4th root of 625, well, that's just going to be 625 to the 1/4. And then I can calculate that as 5. 5 times 5 times 5 times 5 is 625. And I can put that in my calculator and figure that out. Now, these can be combined with some of our other exponent rules to do some calculations. And so we're going to try a few different things here with them. The first is we're going to try and write the following as a single power. And so if we take a look at A, we have the 3rd root of 27 to the power of 2. Let's try and write this as a single power. So we'll start with what's in the brackets. That's the 3rd root of 27. And so we know that we can write 27 to the power of 1 over 3. And then we still have the power of 2 on the outside. Now, using our exponent rules, we know that 1/3 times 2 is what we have to do to simplify this. And 1/3 times 2 is just 2/3. So when we have this situation where we have a fraction and then a whole number, we can just stick the whole number on top of the fraction, and this cubed root of 27 squared is going to be 2/3 as an exponent. And then you could actually calculate that just doing 27 to the power of bracket 2 divided by 3, and you're going to get yourself 9. The cubed root of 27 is 3, because 3 times 3 times 3 is 27. So the cubed root of 27 is 3, and 3 squared is 9. And that's what this does. It does each one individually. So the next one here, we have the square root of 2 to the power of 4. Well, 2 to the power of 4 is inside the root, so we're going to keep that inside a bracket. And the square root is just 1/2. So there's our square root. And now we got to multiply that out. So we have 2 and then 4 over 2. 4 times 1/2 is 4 over 2. Or, that's just 2. 4 divided by 2 is just 2. So we have 2 to the power of 2. And that simplifies it down. So whenever you have your root, you can write it as a fraction. And then if you have the multiplication to do, either with the exponent on the outside of the bracket, the integer exponent on the outside of the bracket, or the integer exponent on the inside of the bracket. Both cases, you end up with the same idea. You have the integer on top and then with the fractional portion on the bottom. And then you can in this case, we were able to simplify as it was able to. Here we weren't able to simplify 2/3. So we can write these out quite easily, and then we can do those calculations in our calculator. Makes it easy, especially when in a lot of cases we don't have a root button available to us for some of the different functions. And now if we've got to do some evaluation, there are some cases where we have negatives that can mess around with these exponents. Whenever we have a negative number that we put to an exponent and we find that power, it works out where it's either going to be a positive or negative number. But it doesn't always work in reverse. We can't take the square root of a negative number, but we could take the cubed root of a negative number. And so we take a look at this one here and see what happens when we try and work it out. This is going to be the 5th root of 32. And if I type this in my calculator, so I'm just going to evaluate that. Negative 32 to the power of bracket 1 divided by 5. And I get -2. And we can see that if we have -2 to the 5, the opposite, that's -2 times -2 times -2 times -2 times -2. And that works out to -32. We have two negatives make a positive, these two negatives make a positive, and we're left with the leftover negative, leaving that as negative. But if we try and do -16 to the 1/4, well, let's see what happens when we type that in the calculator here. -16 to the power of bracket 1 divided by 4. Non-real answer. And it gives me an error. So what happened here? Well, I know that 2 to the power of 4 is 16, because 2 times 2 times 2 times 2 is equal to 16. But if we try to do -2 to the power of 4, well, that's -2, -2, -2, and -2. We have an even number of negatives here. These two make a positive, these two will make a positive, and we're going to be left still with positive 16. If the number here is odd, then I can have a negative answer, because I'll have that leftover negative number. It won't have a matching negative to make it positive. But here, it's an even number as our base, our denominator in that, so we always will pair off, we'll always get even numbers. So just something to note, you will get cases where you can't get an answer. This is not possible. That only happens if you have a negative base and the denominator of the fraction in the exponent is even. And so now you got some practice you can try out with these questions.